Hey, what's up folks, and welcome back to another 3D Hangouts. My name is Noel Ruiz. I'm a designer here at Adafruit, and joining me every week is Mr. Pedro.
What's going on, everybody? I'm Pedro. Creative Tech here at Adafruit, and every week I'm come to share 3D printed projects featuring electronics from Adafruit.
That's right, this is a show where we combine 3D printing and DIY electronics to make inspirational projects. Let's jump right into the show. This week's coupon code is NeoPixel. So if you want to pick up anything in the Adafruit shop, this will work on all of the things except for gift certificates and subscriptions to Adabox. But everything else is really good, such as printers and Filament and all the things in between. If you head on over to adafruit.com/free, you can see all the different deals that are going on. If you spend more money with us, we give you more free stuff. Orders that are, $200 or more, you get free shipping, which is great here in the US continental areas. So check out the website, adafruit.com/shipping. We also have same-day delivery as an option if you are in the New York City area. So head on over to the site and see what's going on there. When it comes to product-focused newsletters, we have one a week because we try to get new stuff in the store every single week, no matter how small. So go over to adafruit.com/newsletter and find out all the new products that happen every week. Yeah, that's right. All right, we also got another one here. This one is another newsletter. It's a daily digest, adafruitdaily.com, standalone website. You can opt in. Nobody is automatically subscribed to that because that's a scummy thing to do. Thank you, companies that do that. So adafruitdaily.com, that's where you want to go to get your daily newsletters for all things 3D printing, biohacking, and CircuitPython. There's other categories as well, so check out the site and opt in. Our crack team likes sharing posts and whatnot from the community, so you'll find a lot of stuff there that you may have missed. Okay, we're hanging out in the Discord chat room. That is a great way to get in the community and let folks know what you're working on, or if you have any issues and things like that, you can also use Discord for project help. So check out, we're in the live broadcast chat room right now, and there we are. Hello everybody, good morning.
Hello to everybody in the chat room over on the Discord. We got Troy, Dune Wester, Andy Calloway, Mattable.
Hey,
on
folks.
the YouTube chat, we got Jim2386,
Hey, Jim.
James, Henry, Christo, Charles, Tony, Thomas Veach,
Hey folks.
and Dave Estelles.
Hey Dave. Very cool. I was switching around through the Discord and the other chats. We are live streaming on all the different social networks, Twitch, Facebook. Hello everybody. And then this video will be an archive after the show. Very cool. Let's see, what am I missing? The jobs board, if you are a maker and you're looking to get paid for your maker skills, head on over to jobs.adafruit.com. We are looking for some PHP developers to work on the website and other things. Or maybe you have a job category that doesn't exist yet. I know I was one of them, so check out the jobs board. And if you are also an employer looking for employees that have maker skills, you can post up a job listing for free, and you can also make a profile for free because open source is awesome like that. All right. Jumping back over to this week's coupon code, it is NeoPixel. So don't forget, this helps out the show and helps you with your orders because it gets you 10% off all the things. So check it out. Yeah, I think I'm kind of ready. We'll go back over to the chat room, see if anybody's got some dire questions. We'll answer questions and communicate with the chat as we go. So for now, I think we are going to jump into this week's project. After I get confirmation from Pedro.
Yes.
Yes. All right, cool. I got the Learn Guide tab open. So heading on over to learn.adafruit.com, you can see all the guides that have been released. This one is the newest one from ourselves, yours truly. This is a CircuitPython project. It uses the BLE feather. That's the NRF 52840. It's the newest awesomest Bluefruit feather that we have, and it now works with CircuitPython. So that's the main thing about this. So let me do a quick demo. If I head over to my overhead, I got my hat. It's got the NeoPixel strip. That's this week's project. I'm going to go ahead and open up our Apple Watch, and I'll tap on that Adafruit icon like that. I didn't even have to tap it, I just used the crown. And now I have some buttons, right? I got 4 buttons. Each button is going to trigger a different LED animation. So if I tap on the button number 1, I got some rainbows. If I press button number 2, I've got some other watery effects. Button number 3 has more of a fire effect, and button number 4 has like a kind of like an ice blue water kind of gradient. And we can take a look at them under the overhead, just kind of show. So the different thing here is that they are controlled with the Bluefruit app, and the way it's set up is that we can either use the control pad or the color picker. So go ahead and unlock here by looking at the phone, and here's the Bluefruit app. Bluefruit app is free to download. There is also an Android version, and the Apple Watch version just kind of comes with the iOS version because that's the way iOS works, right? So the way to use the app, I got a little black dot there on my phone. Way to use the app is to click on, well, first you want to look at all the different, in central mode you can see we got all the different devices here that are Bluetooth. I have one that's called Circuit Pi, which is right there. You can click on it and see stuff. Click on that connect button. It connects to the Bluefruit, which is inside the hat. We'll take a look at it in a minute. And then here's the controller. What would you call it, module? Mm-hmm. And then you have a list of other modules. You can either choose from the control pad or the color picker. The color picker is a little bit more detailed because you have brightness right here, and you have a nice little color wheel that you can use your finger to tap and kind of drag this little eyedropper around to pick whatever color you want. Again, the bottom right here gives you kind of the brightness intensity, gives you a nice animation as you kind of scrub through it, and it also tells you the RGB values there and a hex value. That button right there, send select color, what does that do? Well, it did nothing because I didn't tap it correctly. There we go. And you know, fingers and tap. So you can change the brightness, which is super handy if you are indeed at an area where you want to turn down your brightness quickly. You can do so. This is also, it's a little bit different on the watch. So if I use the color picker on the watch, I have options to do palettes, which are preset colors. The palettes just look really good, but you can't control the brightness intensity. So we just do full brightness. That's white, that's purple. They're all like kind of the 100%. So let's say we want to do something more dialed in. You can tap on RGB, and then you have these 3 kind of plus and minus buttons. You can really dial in that color, send that color. You get a little preview there. I think that works okay because you can control the brightness with this and get a really precise color. I think, yeah, it's happening. But I like using the app, the actual app, the phone app, because obviously you have so much more room to work with and a lot more real estate to kind of pick and choose your different colors. So that's working out pretty well. It's pretty solid. The connection's pretty good. It stays connected as long as you have the device on. And that's just a quick little demo of using the color picker and the control pad on both iOS phone and iOS watch. Very cool. One last feature I think I forgot to mention is these arrows. We do use the arrows. The up arrow will increase the speed of the animation, and the down arrow will decrease or slow the animation down. Now this is where you really can kind of see the kind of performance that you get with CircuitPython and a bunch of NeoPixels. This is 49 pixels. You can see here it's starting to struggle a little bit. I'll let you guys know that there is some work happening with performance on NeoPixels and CircuitPython. It's going to be called, I think, Pixel Buff, which will make these pixels hopefully nice and smooth. So we're working on that. But for now, you can totally use it, and it's workable. The more pixels you add, the more memory that it's going to need. So that's a good look at what it looks like performance-wise. Yeah. With some of the effects, they kind of look a little bit more smooth than others. For example, this one, it's looking a little bit more smooth. So there you go. All right, well, that's a demo. Let's go ahead and jump over to the Learn Guide. As I wear my hat.
Real quick question from James is asking, he wants to know how to evenly distribute power down over a length of a NeoPixel strip.
Definitely check out the Uber NeoPixel guide. That one's going to walk you through the best ways to power tons of pixels. So if you go to the Learn Guide, over here you can search at the top.
Posting in
Uber, and this is it right here. and then we have powering the pixels, and it'll walk you through all the different means of powering. Nice good read there.
Yeah, so the quick answer that I gave him on the chat was that I see most people using both ends of the strip to add power. Doesn't mean add 2 lipos, it just means connect both ends of the strip to the 5 volt.
Yeah, sometimes you can even do it in the middle of the strip, which I've seen in some projects. Yeah, I would say something like the Cyberwig uses so many pixels.
Check this one out. The
NeoPixel curtain
from Phil B. I just put it in the chat as well.
Look at this one.
So this one uses 15,000 NeoPixels. Let's see how Phil B did the power distribution on that. Check that one out. Oh, he has a power topology.
Don't mess around, folks.
So definitely read that one.
Good, look at this thing. It's a dragon.
It's got fuses on there.
Now that's how you power your pixels.
Yeah.
Fuses, and you have a servo, and you have a bus bar, and you have all these bus bars. That's gonna, and there's lots of infos here. How about an ATX power supply and all the different things. It's definitely a good dive in there. So check it out. Phil B's the man when it comes to the pixels, man.
For the data pin, I think it just goes to 1, but for more specifics, definitely post in the forums. We have dedicated engineers that check out that form and
that's getting,
answer your questions, because that's what you pay for when you get Adafruit stuff.
That's correct. You get that support.
Definitely check out the
If you don't pay for anything, we still help you out, even if you got other stuff. Check out the Discords. All right, cool. That's a good little insight there. The way I'm powering mine is just with a 500 milliamp battery. The feathers all have the JST port for all the batteries that we carry in the store. So there's not too much trickery there, and I'm only powering 49 pixels, which is kind of low. All right, let's head on over to the Learn Guide where I was before. Here we go. There we go. CircuitPython, BLE Hat. All right, so the first page is going to walk you through the overview of the project, pretty much what we demoed. Here are all the parts that are used in the project. Mainly it's that feather and our F52840. Definitely sign up for email notifications when they are back in stock, because they are not in stock right now. So we are making more. Another thing is these crystals. We'll talk more about them, but they are just a really neat way to kind of make your LEDs not look like LEDs. They look more like they're kind of meant to be jewelry. So these are really nice because they don't have a foil backing, and they have that rainbow iridescence, so they're kind of diffused and looking nice. They're going to fit on any of the LEDs, so they fit on the 35 footprints and the 50/50 footprints. Those are just the sizes of the different NeoPixels, which we'll talk about in a minute. So the battery is a 500 milliamp battery. It's only 3.7 volts, but the voltage regulator on the feathers all make it nice and smooth, so you don't have to worry about putting any extra stuff on it. That just plugs in directly to the feather. We got some wires here because we are going to use a switch, a little slide switch, to turn off the regulator so that we can still recharge the battery when we want to turn the LEDs off. These are some tools, my favorite tools: Third Helping Hands, the Stickvise. These are all great things to have if you're just getting started. Slowly build up your arsenal of tools. We got the Hakko wire cutters, flush diagonal cuts, and these are really nice JST cables. They're like quick connects, so you can quickly disconnect strips and stuff to your board, which I can do a demo in a minute. When it comes to the LEDs, I have 3 different densities. They're all mini skinny, which uses the footprint 3535 LEDs, which are a little bit smaller. That's what you're going to see on the Circuit Playground. And we can kind of take a look at them now, I guess. So let's do the overhead again, this one. And you can see here, this is another hat. And this has the mini skinny. And you're like, well, what's so mini skinny about it? It looks the same. Well, when you put it up to the regular one, you can see just how massive these are. And this might be the look that you're going for, or it may not. So this is the look I was going for these smaller. It's about half the size, almost, it looks like, huh? And the other thing I'll do is look at these. I had my own kind of bedazzled crystals on hand, and they had foil backing. So what I did was I sanded the ends, I sanded the backings, and that just makes them it gets rid of that foil, but it doesn't really diffuse them at all. You can still see the LED elements, and they don't look that great in my opinion. And they look more bubbly. And I still use super glue though. Maybe that's the look you're going for, but it wasn't really looking that great for me, and I was happy that it took Lamar a minute to find these type of crystals that don't have a foil backing, but still have that rainbow iridescence. Because I think she saw something where folks, like some fashion company or something, was like making pixels with built-in rhinestones, and we're like, well, we can do that. So we did. This looks great. This is also another look at what happens when you use too much glue. Not super glue, this is hot glue. You can kind of stain this fabric here on these type of hats. Reason why it's stained is because I had this strip across it first, and I used more glue, I ripped it off, and then I put this one with more hot glue, and it left this kind of nastiness there, which I can't seem to get rid of. So my second one, I made sure that I didn't use too much glue, and that makes it look nice and even across the hat. And boy, was this so much easier than, well, sewing each one in there. You don't have to, you could tack it down. I think that's what I did a couple years ago, and that was very time consuming. So using some hot glue to fix it there works out really well if you're in a time crunch. If you got like an event, like, oh no, this weekend I'm going to Disney, I wish I had a cool hat with lights in it. You can do it in a day because the hot glue just dries up real quick, and you can solder this up real easy by following the tutorial on the Adafruit Learning System. So let's head over there and take a look now that I demoed some crystals and stuff. Come on, buddy, get with me. Here we go. So those are the LED strips. Really weird issue here. This is $99 for a 60 per meter. That price reflects a whole reel, which is like 400 pixels. If you actually go to the product website, you'll see that 1 meter, which has 60 LEDs, is only $25 and not $100. That's the 4 reel. So if I click on that 4 meter one, you'll see that it's $100. That's because it's like 400 pixels, right? So this is the real price. We'll work with our internal dev team to see why is that price showing for the full reel. So that's just a little note. But the other ones are pretty good. We have a lower density where it has 30 pixels per meter, and they're just more separated, and they have less pixels on the strip. But you still get a meter of them, and there's only 30 in that meter. So depending on what kind of effect you're looking for, this might be good, because maybe you want something more that has like a marquee effect, where the distance between the lights doesn't really matter, or maybe you're looking for that aesthetic. So many choices, and I figured, put them all in here so folks know that there are lots of different sizes of the mini skinny variety. So there you go.
There's one thing that we forgot to add onto that product page.
Yes, we're going to get to that. We're going to get to it.
Okay.
I got a whole thing about it as we get there. All right, let's work on over to the circuit diagram. We have the fritzing file here. If you're wondering how we create all our lovely wiring diagrams, it's with free open source software called fritzing. We also have a library that has all of the Adafruit boards. So if you want to make your own fancy looking wiring diagram, you can do so. Click on that link, and you can download the the actual circuit diagram here in this file, where you can modify the wires and stuff or reuse the parts. Very cool. So let's just look at using 3 wired connections to connect the NeoPixel strip, and a slide switch uses the 2 wired connections. We're going into the enable pin and the ground pin. Whenever you tie the enable and ground pins together on any of the feathers, that shuts off the 3-volt regulator and allows you to recharge whatever battery is hooked up to the JST connector over USB. So you can charge. The circuit is kind of separate from, the charging circuit is kind of separate from that 3-volt regulator, and we're using that 3-volt regulator to give us 5 volts. I know it says 3, but the NeoPixels don't get too mad if you give them a little bit lower. But that's working out okay, because we're only using 40 pixels, or 49. So that's there. You can download the wiring diagram and follow it. When it comes to the software, shout out to the CircuitPython dev team. Dan Halbert and Philip Burgess worked on this code, and this page will walk you through setting up the NRF52840 feather with the latest version of CircuitPython. I have a direct link here to it, so when you click on that, I opened a new tab, you will get the circuitpython.org website. This is where you can get the latest version of CircuitPython 4, all of the different hardware that is supported. In this case, it's the NRF52840. You can download the latest release. We're pretty much caught up with the beta now, so it's pretty stable. And it has native USB, so you plug this in, it shows up like a USB drive, and you can drag and drop your code in your libraries, which is amazing. It's pretty mind-blowing. So going back over to the website, really easy to flash a firmware. You literally download this one file, you double-click on the reset button, and it just shows up like a USB drive, and you drop in that UF2 file. Some magic happens. You get automatic flashing firmware. No need to compile with Arduino because it's all being done on the board. It's pretty amazing. We got a CircuitPython library bundle. You download that zip. It's like a megabyte and has like all the libraries that are currently for CircuitPython. And you're going to want to pick these 4. We got the BLE library, the Bluefruit Connect library, the fancy LED library, that's what's managing all the animations, and the NeoPixel library, which kind of, I guess, handles the registers and stuff for the NeoPixels. So there you go. You just need a little handful of libraries, drop them in your lib folder, and you can grab the code. When it comes to editors, we really like the Mu editor. It's a Python editor, built in Python, works on Windows, Mac, Linux, Raspberry Pi. It's got Serial Console built right in, so you don't need to download any other plugins or stuff like that. Oh, I hit the wrong button. And you can follow the tutorial if you want to learn more about the Mu Python editor. But it's built for beginners, so it's going to be really easy and intuitive. So I think you'll be good there. Here is the code. Fancy LED palette and color picker controller with the Bluefruit app. Code by Philip Burgess, Dan Halbert, and Aaron St. Blaine. Shout out to you folks. This is the full code. You can run through it. And if you run through at the bottom here, I have a little screenshot that kind of shows you, where you want to click to use the BLE Connect app. I also have a link to the iTunes store, which I guess is just the App Store. And also the Android link to the Google Play Store. Again, these are free downloads, so you can use them on your devices. When it comes to kind of creating your own pixel strip setup, it's really easy to adjust it. This line is where the NeoPixel object is going to be created. We have 2 values here, D6 and 28. So if you want to change your data pin to any other ones, just make sure the code reflects that. And the number 28 is the actual pixels that are in this project. I thought I was using 49 for some odd reason. You know what? The number 49 is from your Mickey ears. That's where I got confused. I'm actually using 28 here, not 49. So if you do have different pixels, so if you actually use a different pixel density, if you use the 30, for example, you're going to have less here or more. So just make sure that your numbers are reflecting your actual setup. You can totally customize the palettes in the animations. Just read through the comments here. You can see how the colors are being arranged. If you just want to change the arrangement of the colors, it's as easy as kind of swapping out these colors. It's using RGB values, so it's just those 3. It's using like an integer of 1. So 1 is 100% and 0.1 is 10%, right? So that's the way these are working. And you can see the different effects here: palette water, palette fire, palette gradient, and palette rainbow. Those are the effects that are a part of the fancy LED library. And then you can just come in here and change these values as you want to create a completely different effect.
Yeah, Andy Calloway was asking, no Cylon effects?
I think that's Cylon effect would be cool. I think you could do a Cylon effect if you just make, like for example, this one right here, the fire. If you just put more black and then have one in the middle, I think you'll have that Cylon effect where it bounces back and forth. Maybe. It might just go back like this and go in one direction. So that might be a little bit trickier. But hey, these are some great effects to kind of start with. Cool. So that's the software, really run down and quick like. Excellent. All right, let's hop on over to setting up the NeoPixel. I'm using a snapback adjustable hat that I got from lids.com. They tend to make these type of hipster hats. I don't know what else to call them. Measuring out the strip, you definitely want to, take some time here, figure out exactly how you want it, where you want it. Mine was really, really simple. I was like, how is the simplest way I can get these pixels on my hat? Just having a strip across the front was the easiest I could come up with. When it comes to kind of the flow of data, it's always important to know. Most of these strips have markings on them. There are a little bit different. So for example, whoops, wrong. Where is it? E? F? There it is. For example, if you're using the bigger size NeoPixels, you'll see that on the actual strip here on the front, you can see that arrow. This one is the first pixel, and the arrow goes that way, so that's how the data is coming in. So it's going in and going this way, and it follows through like that. If you are using the mini skinnies, however, they do not have markings. Well, they kind of do. Mine's actually going this way is the start, and you really can't see them there. So there is an arrow right there, but the NeoPixel element is kind of covering it. So what you do is you flip it on the underside, like it is in the photo here, and you can get a better look at that. And the way I'm cutting it is I'm actually cutting off that first pixel because it's easier to get to the pads than it is to kind of remove this. If you click on any of these images, they'll get bigger, and this is the bigger one, so you can see here. Where you want to cut it, I actually cut it right there. Oh, there's where you can see the arrow. You want to cut it right here. There's actually a NeoPixel right here, but like I said, there's so much glue and crap there that I just cut that first pixel off and gave me that clean 3 solder pads that I can add a lot of solder to, or solder, whatever. So yeah, that's me right there, putting my thumb over that first pixel so that we can just, save us a lot of time. And then the end pixel, where do you want? I kind of lined it up with the seam here of the hat, and that's kind of where. So 28 pixels is where I have it there. So I'm just going to cut that right there, giving me 28 pixels. So I call it the sacrificial pixel because that pixel can no longer be used now because I cut it right there. So I cut it, instead of cutting it across that line, I cut it beyond that so I can have that full access to those pads. This is going to be my starter pixel. That's what's really cool about these strips is you can cut them and still chain them together and create different shapes and whatnot. So I just use my flush cutters, my diagonal flush cutters, and cut right through that whole thing. The silicone cuts like cheese. All right, and this one shows you counting the pixels. I manually count them just to make sure that your setup is actual. And then here's what it looks like. Cutting the strip at the last pixel where your hat is. That is where you do want to be nice and in the middle so you have sufficient amount of padding on both ends of the strip that were cut. Cool? Cool. Here we go, extra bling. This piece of the guide shows you how I got these crystals on here. Now this is a little tricky, mainly because the crystals they have this odd shape. Can't really grasp them well. Tweezers are, maybe there's a
slip right out.
Yeah, I couldn't do it with tweezers, and I did get super glue on my fingertips because that's the best way I found to actually attach the crystals. So you just want to be real careful. I use the third helping hands to keep the strip level and in a good position while I kind of finesse my fingernails in place. That you get a little bit of work time before the glue sets and dries. So you just want to do your best, I guess. I don't have any other tips other than it was tricky and be careful with it. But you do really get some nice results here with your gems.
The only other thing I can think of is making like a 3D printed jig.
I thought of that, but it's like that's too much time. Yeah. I only have 28 to go. Let's go. So yeah, maybe we'll come up with something better. All right, now wiring up the pixel, the strip rather. You're using the JST connectors. We like these. They're small enough to kind of fit through different areas, and they got a nice hold to them. Super easy to disconnect. I'm going to cut them short, about an inch long or 25 millimeters long. That way they're pretty close to proximity of the actual strip. And we're going to tin them, we're going to solder them. I walk through all that here, and we end up with a nicely soldered strip that we can plug and play, because it's real nice that it's not actually soldered to the board itself. Because now we can come in here and take out the board, so you can see it there. Let's go ahead and jump in here. There's nothing really secured to the hat yet. There it is. I have it loose, so what I can do is just take this flap out. You see my board there. I'll go ahead and shut it off. I got the slide switch in the back there. Now I can unplug this, and now I can wash the hat or do something else with it, because that's all it is, just this guy right here. we can plug this in and we can start charging the battery. Notice that this right here is the orange LED. That means I'm charging the battery. And because the regulator is switched off with the enable pin, I don't have to worry about the pixels turning on. Now if I do that, if I do turn it on, this will turn green, let me know that CircuitPython is running A-OK, and the pixels would be running here. And it's still charging. Very cool. So I'll go ahead and turn it off and it's still charging. Very cool. Micro USB all the way.
For now.
For now, until we get C. So cool, I just took it out of the hat in like a couple seconds. I did take this to Disney, and it did rain because we're in Florida in summertime. And my hat got wet, but it was fine. I just made sure the circuit was off, and then it dried out, and it's still working today. I took this very one. I didn't sweat too much in it, which is great. And it doesn't smell too bad either. Very nice.
Yeah, Shadow Ninja on the YouTube chat was saying that probably tack it down with stitches at each end and then one in the middle.
That is a great idea. That way it's, because every time I do take it off, it does kind of slip out. So anybody that wants to do that, you totally can. There's enough.
Oh no, you're talking about
here.
the strips.
Oh, the strip?
Yeah.
Oh, and you can tack it down with sewing. Yeah. Yeah, totally. I did that in my first version a couple years ago, but again, it was time consuming and
yeah. Well, it was good to know that we were out in the heat and it was able to hold up.
Correct, yeah, and it's hot out here in Florida, South Florida, mind you.
But if you're going to be doing like tricks and stuff with your hat or, you know,
you definitely want to sew it in, yeah.
Definitely recommend
You can
sewing
definitely
it.
sew it in because there are these little holes that will allow you to, I guess, get a really thin. Yeah, you see those holes there?
Definitely do that.
Hopefully that'll help you out with sewing. So you can tack it down there. We also have another version that's way more advanced from Becky Stern, the wearables mistress herself, that uses UV stuff. So you can check that out on the Learn. Cool. So that's how I wired up the strip, wiring up the feather. Definitely shout out to Stickvise. They make a great product, simple PCB vise, probably the best one out there in the market. And that's how I get my solder joints super clean. I use the Stickvise. No, it's a good one. It's really good. And then I got that female JST connector wired here, real nice and short, so that as you saw in the hat, it's a close proximity. You can plug it in, make sure it fits. For wiring up the slide switch, I'm using the silicone stranded wires, just a small little kind of inch long because it's going to be on the back of the feather anyway. We only need those 2 pins, one of them in the middle and one either side. So that's going to be tied to enable and ground. I picked on the bottom of the feather because that seemed to be the best spot for it, and I'm also sharing the ground pin, which is also the ground from the female JST connector. So just add enough solder so you can kind of share that ground pin. Now you can plug in the battery, and is Bob your uncle? Somebody's your uncle. Lamar's your uncle. No, it's Lamar's your aunt. All right, so now that we have the circuit, you can play around with it and start fixing it to the hat. We just kind of walked through it. Now, making a hole in the hat, I did this really good in my first version, and what you want to do is you want to pull apart the seam. You don't actually want to cut the fabric. So in this version of the hat, I was able to get my hobby knife to separate the seam so that it looks much cleaner. Come on, camera, focus, will ya? Much cleaner. So you can see there, the way the fabric, the way the seam is, it's kind of folded, so you don't want to cut right there where that fold is. Because if you do, you tend to kind of fray the edges here. So you can see here that I did actually cut, and you can see that fraying happening there. And that's not ideal really, because the more you play with it, the more it's going to come undone and the more the fabric's going to undo itself. So you want to be careful not to actually cut the fabric, but to pull apart that seam. You can use a seam ripper, or as Pedro found, you can use this guy. We have a special blade that is not made from metal, but made from ceramic. Who would have thought of such a thing? This is from Slice. And we have a couple of different ones. We sell them in the shop as well. Here's one
for box cutters, and then we have another more smaller type one, like to hold as a handle. But these work excellent for ripping through not only 3D printed items, like for cleaning up brims and like pieces of overhang, but as well as fabric.
Yeah. So if we head over to the product page, you can see here we are cutting it with it's pretty sharp. So be careful with it. It's meant to cut cardboard, but it also works with other things like 3D prints and fabric. So it's just a nice, high-quality ceramic blade. Very cool. So check that out. I didn't use it in this project, so that's why I didn't link to it. But that's the tip. I use the regular old, nasty, rusty blade. But once you have the hole big enough, you should be able to shove that male JST connector through the hole, and then you can pull the wiring through. So I have a hot glue gun that's cordless, battery powered. Definitely pick one of those up if you don't have one. If you're using that corded blue one from Walmart, man, you need to upgrade that one, because we were using that for years, and it ain't the best thing. It's kind of the worst thing. This one has really high temperatures, so you're going to have a stronger bond. You can use that Gorilla hot glue, which is really sticky. And this one has a fine tip nozzle, so you can apply a line down that thin, narrow strip that is the NeoPixel strip. And then you can be careful when you're actually laying it down on the hat. If you are a little bit crooked, you're going to see it, so you want to make sure it's nice and straight. And then just kind of do it at sections at a time is what I did. Yeah, and just make sure you don't get any hot glue on those edges. If you do, I guess it's okay, because you can kind of use this ceramic knife to kind of trim out any excess that might be squeezed. What do you call it? Squeeze out. So you want to trim that out, which is what I did, just a tiny bit. And they look really good. Here's a macro shot of the thing. It looks freaking awesome. And there you go. That's pretty much the whole Learn Guide. We walked through the whole thing, and my goal was to make a really good kind of easy project. It's not really that easy when you involve all the different components, but I think it's been harder before, and the goal again was like, hey, I have a trip that I'm going to go on. I need to make this in a couple days, and you can totally do it. You can totally make this in like a weekend. So there you go. If you haven't worked with LEDs yet, this is a really fun project to get into it. Same thing with the Bluefruit. If you haven't done any Bluetooth controlled stuff, CircuitPython really makes it freaking awesome. Actually, instead of putting this back on my hat, you know what we're going to do? We're going to take a look at Shop Talk, and we're going to look at a different style of NeoPixel that we haven't seen before. Actually, I am going to put it in the back, because I got a video.
Okay, so first, it should be on what are we prototyping, because this involves
good. Well, we are now in the prototyping segment. Let's check that out.
Yeah, so when we showed off the hat, Lamar thought it was cool, and we mentioned we were going to take it to Disney to take some shots. She was like, why aren't you making some Mickey ear hats? So, made some Mickey ear hats. Yay, so we've seen these, I think in like 2013 we had a really good guide on, was it on our blog and on Instructables?
Yeah, it was on our blog and Instructables.
They were using, I forgot what it was, but these awesome little side-lit NeoPixel strips that we haven't used before. I said, these might be really cool to add on, so you don't have anything in the back, blinding people from behind you, because that's one of the etiquettes at Disney, not to have those. You can blind people or having your phone up, especially during shows. Yeah,
like a light that's ruining the show.
When it gets dark, your eyes already adjust to the darkness.
So this shoots more out ways that way. So the folks behind you that are trying to watch the parade, they're not going to be like, man, this guy, freaking lights, gosh.
Yeah, so some cool techniques that we used for this one, we're using a trinket on for the microcontroller, and then the side-lit NeoPixel LEDs, and then we used maker.makecode to program these, all the animations on here. So it's just in drag and drop.
I programmed this myself. I can't believe it. Thank you, MakeCode.
And what was so cool is that they had all of the libraries in there, that they had the LIS3H, which is our favorite little accelerometer. So I attached that to the trinket, it builds out your little circuit diagram of where all of the connections need to go. And I don't know where we are. Are we still focusing on me?
Of course we are.
So we have some motion activated lights here. So when I shake it, you can see these really cool little firework effects.
This is awesome. So you add that little bit of interactivity with the accelerometer. So I want to change the effect when I shake my head. And there you go. This is really cool because it kind of blends into that other color. So these are canned animations that are part of MakeCode. And well, we can actually step and look at it right now. This is all kind of your block-based editor, right? So this is all the code that's running on the Mickey ears. So you can create a strip, you can create a forever loop. These are the four animations that we have. On shake, we want to stop all the animations, and we want to run the sparkle animations for 300 milliseconds. And that's it. This is the shared code that is easily modifiable. We can hit this edit button and edit it, or we can run it in the simulator. This is bonkers. This simulator generates these wires for you, and will actually preview the LED animation. There's 49 pixels in this one, so you can see that there's 49 of these little dots. And the reason why this is kind of moving is, well, it's replicating the accelerometer. So I'm tilting it in this sort of area, and when I shake it, if I shake it good enough, you'll see that there are the animation happening there, the sparkle effect. And you get a wiring diagram as well. Duh, I forgot. Like, here's how you wire that accelerometer. This is freaking brilliant. And there's a switch over here for JavaScript and Python. So if you want to write this if you want to convert this in programmer syntax, there it is. It's only 31 lines of code. That's ridiculous. I'm going to stick here in the blocks, though, because that's where my designer brain likes to live. So that's awesome. And you don't need an account or create a Google account or link it to Facebook. This just runs on whatever computer.
Just looking at your cookies or something.
Yeah, something like that. And yeah, there it is. So yeah, shout out to Microsoft. It's all open source as well. This is all on GitHub. You can run this on your own server, which is what we did with Circuit Playground. So there you go. That's a really quick look at them. We're going to do a whole video and walk through it because it's mind-blowing to us because we haven't really used Maker's MakeCode. We've used the Circuit Playground version of MakeCode for a little bit now, but it's really great that this works with any of the M0 boards from Adafruit. So that's the Trinkets, that's the Gemma.
And it's still pretty new. I think it came out last year in December when we first started hearing about it.
Right. And just having the simulator here really makes it doable where I don't need to have the hardware with me. I can play around with the code and make that interactivity work the way I need it to. So I guess jumping back over to pages overhead.
Look at this guy.
Yeah.
Let's build this little animation. I was super proud in the way that everything is nice and clean, so you don't have all these crazy components.
You see that, guys? No? This right here is not. This is a ribbon cable. It's so clean to use ribbon cables. Because you don't have to use a bunch of heat shrink tubing, and it looks like a ribbon.
Yep. So these are the silicone coated wires.
Actual ribbon. So yeah, silicone wires are really strong and flexible. That's going to work the best here.
Yep. And all the components are just attached to the back of the ear, so you have plenty of room to add even more sensors. Like if you wanted to add a microphone and make it UV reactive, that'd be pretty cool.
Yeah. Again, this is like the most minimum kind of craftiness that you need. Really, all the hard work is done in really fine-tuned soldering to make sure that your wire lengths are freaking perfect and that all the seams are hidden. It looks great on the outside and on the inside.
Shout out again to these.
So you're able to cut this
porcelain.
thick,
not porcelain. I keep calling it porcelain. Ceramic blades. We're able to cut through this really quick. I was using the regular, steel. Or whatever
that's gonna fray your edges, huh?
They were fraying right away. Cut through this like butter right away, like 3 little cuts, and it was all the way through. And as you can see, this is not light; it's pretty thick.
$30 ears, man.
And then down at the bottom here, they have these nice fine threaded, whatever this is, like spandex or something.
Right.
So it was able to cut through that.
Let's look at the other Mickey ears. Not all Mickey ears are created with the same fabric or material.
Yep. So right before I started to film all of the assembly of this, had to go get some more ears because this is, we always have to build like things 2 or 3 times.
Figure out how to build it good, and then document that good build.
So I'm going to add it to these ears, but we got these in stock last week. These are the mini neon NeoPixels. So we take a look at these. They are like the side lit ones in terms of that they are facing over to the side.
And you can cut
plug
them.
These in.
They're pretty chunky, but they're still using that mini skinny, like Pedro said. Let's look at a video of us yesterday testing out the
it's really a comparison of these guys. So because it has a little bit of the distance between where the transparent part of it is, it gives this beautifully diffused effect that looks just like neon.
It looks so
this
good.
is what we're going to use for the actual build, because the marquee effect, looks pretty cool.
Yeah, the marquee
Being
effect
able
is
to see
like
each individual pixel,
Yeah.
but I think this just elevates it in terms of having this really cool neon looking effect on your ears.
I like them both. I think they both look really good. They have their own aesthetic to it. I like the marquee look. It works for that kind of classic kind of theme, whether it's a theater theme or like the old school Disney classic. I like the marquee effect too. And yeah, this neon is really nice. Now the neon's only shooting at one face. It's only one direction. And here's the product page so you guys can look at the price and
pick some of these up for everybody
$35
grabs
bucks.
them.
Yep, so it's got 96 pixels. It's just 1 meter. It is waterproof, weatherproof,
Resistant.
or something.
Yeah,
water resistant. So yep, you can cut it. Just make sure to cut it across the seam here.
Now you can
There's
take a look at the
handy data sheet that gives you an exact look at the profile, where you cut it, the segment size. So you can see there's 31 millimeters per segment. And there's some accessories as well here. Here's how to bend it. Here's how not to bend it. You have a minimum bending radius of about 60 millimeters, which is okay. Here's some more power supply stuff. This is a good look at how you want to power it. You want to have your bus here and all these strips. If you're doing a bunch of these strips for an installation or something. Nice. We have all data sheets for all of the products, but this one's just running off of one of the Metros. But hey, you can run it off a Trinket or whatever. It's just your standard voltage, ground, and data, so that it's chainable.
We have chunkier versions of this. It's probably twice the size.
Yeah, it's not
the
a
width
NeoPixel
of it.
though. It's like a 12
Oh,
volts.
that's
This is
right.
the only
That's right.
5-volt
Okay.
version. If you see all the other neon strips we have, those are going to need some more power because they're 12-volt logics.
I chum over the overhead, but for whatever reason, these cameras just can't pick up how beautiful they look in real life.
they're kind of crummy. They're webcams. But you can see here the other ones. These are really, really bright because, well, they're freaking 12 volts.
Yeah.
Yeah. And they're a little bit cheaper. We got these too, but we haven't used them yet because
All the power
we
required.
need the power. Yeah. We want to make some wearables, not some stationary thing. So there you go. There's some
So this will
ideas.
be a project in a week or 2.
Right, the Mickey ears, because we're going to go back and we can get better shots. Yeah, sorry. Yeah, I like it. I like the effect. It looked great. And man, mate code.
I can't wait to
that's
see
so
what the
awesome.
sparkle effect looks like on such a diffused
That would
strip.
be different.
Very cool.
Yeah. Yeah, very cool.
And we'll go over the details on how to get the threshold and all that working really good with the accelerometer.
I think it's default, which is awesome. I didn't have to do much.
Oh.
But you can change the sensitivity if you want,
Yeah.
which is very powerful.
super cool.
Cool, so we got Mickey ears. Yay.
Yay! Oh, you can't see them in the background.
Yeah, right.
Wait. There we go. These are so cool. All the cast members thought it was really cool before I even turned them on.
Yeah, some folks
Turn it on,
saw.
jaws drop, and then I shake my head and their heads explode.
Yeah.
So these are really cool. All right, we'll talk about these next week. Oh, and while we're here, still prototyping and
Yes.
make some Ninja Flex pockets. We love making these to hold all of our batteries, and I just noticed that we didn't have any 1200 milliamp hour batteries pockets for these, or the 500 milliamp hour one. So
Yes.
uploaded these, put them on our GitHub, so you can.
Yeah, these
make
are
these.
flexible pockets for batteries. They give you a little bit of protection to your batteries, and they're printed in Ninja Flex. So that's really nice. It's got grip. It's flexible, and It gives you shock absorbing. If you're making a case or something, it'll absorb that shock. It's kind of shock resistant a little bit. And we actually stock some NinjaFlex. If your printer is capable of printing some flexibles, we got some really good spools that are really nicely priced. These are normally like $50, but we're selling them for $30. You can get 10% off your order of Filament or anything else with coupon code NeoPixel. That's a good segue. We got a lot of different colors as well, and some different diameters. If you got the 175 printer diameters, we got a lot of those. And we have a couple that are in the 285 flavor.
We have it in cheetah as well as the more elastic 85A variant.
So there's different types of flexibles: semi-flex, a little bit more rigid flex, and of course the full-on NinjaFlex, which has got a shore hardness of 85 or 75, forget which one. Yeah, so great material.
Yeah, the way that I'm using these is I'm actually hot gluing these to the side of next week's project, the SpaceX helmet, and then the battery just slides right into there.
They're also sewable and cuttable, so you can cut and sew any prints.
I forget to add those. We do have versions that have tabs on them, so you can sew those down.
Go ahead and squish it like with your hand, like completely crunch it up, how it retains. We made all sorts of fun stuff with NeoPixel. I mean, with NinjaFlex spikes and. Remember all that stuff we made, like all those spikes and horns and all the fun stuff you can make with straps,
search
wrists, gaskets.
There's about 6 years worth of projects on there.
We have a nice playlist as well. Okay, coupon code. So what printer actually printed those pockets? It's this one, the Flashforge Inventor 2. It's got built-in Wi-Fi, it's got a touchscreen, and it prints flexibles really well. Direct drive on the nozzle. And a removable build plate. A little bit small, about 150, right? 150? Yeah, 150 by 140. But it prints flexibles really well, and that's why we love it. That's our printer. We only have 3 in stock. You can get, how much percent off? 10% off that printer. And free Continental UPS. NeoPixel. All right, good.
We're running out of time. I don't know if we could go into... Yeah, let's go ahead and, we'll talk about that next week. Let's go ahead and go into Community Makes.
Oh, right before they got the last tab here. Don't forget, if you want to win a 3D printer, you can. This one is from My Mini Factory. It's in collaboration with 3D Maker Noob, Joe himself. So you can submit your design. The whole point of this one is to kind of create a project that incorporates 3D printing and electronics. That's what we do here, and that's what we're going to promote here. So let's take a look at some of the entries. There's not a lot more entries than it was from last week. I checked this out last week and I was showing you guys some of the entries, and they're still here. They're still up in the front here. So you have definitely some good chances of winning a new 3D printer. Check out some of these cool projects. We've got a windmill. We got this cool mechanical eye, animatronic eye. We got this rotating lithoplane lamp. If you're just looking for inspiration and stuff, it's a great kind of way to do it as well. So there you go. If you want to win a printer, check out this link here. Just go to mymanufacturer.com, look at their contests that they got going on, and you can either submit it or get inspired by other projects from the community. Cool. All right, that's that one. And now we can jump into Community Makes. Let me pull up the Thingiverse page. This week we have a Timelapse Tuesday. This is an Ambiguous Cylinder Cup. Let's go ahead and launch that cup right here. That's not it. That's Megatron. What happened, Pedro?
I didn't put that in there.
Well,
go to the overhead.
I copied it from the YouTube link, so yeah, you put that in there.
Go over to the overhead so you can see this week's.
Hold on, let me actually get the Thingiverse page.
Illusion of this square, circle, cylinder cup. Where am I? There, yeah. This is a cool one that PT actually found. He sees a lot of people doing these really cool illusions where you put like a mirror in front of it and it looks like it's a circle, but when you step away from it or turn it around, it's actually this weird shape that's looking like a cylinder or a cylinder.
There's no
use
way
of that. That's what they did here. This is made by avtkip, Thingiverse. And there's a bunch of examples. If you just search for Ambiguous Cylinder, this is really cool. Use of making something that...
Illusion cup?
Yeah, make it into something that could be useful. I wouldn't actually pour my hot coffee into this
Yeah, right.
Unless it's like PEGT,
Yeah.
PETG.
I found it, you folks. Here it is. Ambiguous Cylinder Illusion Cup by Pedro said avtkip. Thank you, sir, for posting that up there. Have an illusion to go with your, I don't know, pencils.
Yeah, I definitely like the illusion objects that are actually turned into something that could be useful, like I was saying. And this is a nice little mug of it. So when you see it at this angle, it kind of has that illusion of the cylinder.
Yeah.
But then when you turn it around, you can see that it's all sort of wavy. To create that illusion.
Yep. Let's look at the time lapse. We do the time lapses every Tuesday. We use the Octoprint Octolapse plugin. That way we can get these time lapses with the printer head parked away so we can get a look at the part. This is Rainbow PLA, purchased from Amazon.
This one is from Everyone.
It's from Everyone? Nice
It's called
name, guys.
ERY1. Everyone Rainbow PLA.
Yeah.
Has a nice little like shine to it, and it printed excellent.
Yeah. On the Prusa MK2.
MK2S.
Yeah.
So cool.
12 hours to print because it has to park the head and take a picture for every layer. Cool. Again, it's on Thingiverse. We have a link in the description and the YouTube video that shows that what we just shot. Very cool. We have one other community make project.
Was it the stool?
It was the stool.
Yay.
This is a 3D printed stool that we designed a couple of years ago. And SDZ Bensky posted up his make of his stool. They made it really tall for Rampage, the Joust and Defender. This really nice console. We had a light in there, right? We put lights in there. But we also made a version that it's like sitting on a piece of cheese. Very cool. Printed on a CR10S from Curiosity. Hey, that's a...
We'll talk about that next week
Oh,
since
okay,
we're out of time.
We're out of time. All right, well, that's this week's Community Makes. Thank you, folks, for posting your makes. And if you'd like to share your project with us, you can always do so by hitting us up on any of the social channels. I am at Ekin, Pedro is at VideoPixel, and Adafruit is at Adafruit. Very cool. Is our audio still working? Yeah, it's still working.
Yes.
All right. My throat's starting to hurt because I'm talking so much. But don't forget, coupon code NeoCrystal if you want to get 10% off your order. This works on everything except for those gift certificates and the subscriptions to Otterbox.
Which you should definitely sign up for. There's only a couple of spot lefts. Did a blog post, I think yesterday, on some new countries that Otterbox is shipping to. So definitely check those out.
So cool.
And I think that's going to do it for this episode.
The 3D Hangouts. Well, guess what, Pedro? Did you know that? Tomorrow's John Park's workshop, the 100th episode.
Oh.
100.
Whoa.
Very awesome, John Park.
Nice.
Thank you so much for doing it. So tune in tomorrow at Thursday. Tune in.
You're doing this backwards.
I know.
Later tonight,
I just saw it and I got excited. I was like, oh my God, John's doing 100th. So there you go.
So definitely tune in tomorrow. Lots of awesome Make Code demos. He's working on some really cool motion controlled brushes.
I've been,
awesome.
Oh, okay, that was it. I've been seeing eyes, like lots of Maya and eyes.
Oh, that's
UV wrapping and all this stuff. I'm like,
that is for some cool Halloween projects.
Yeah. Yeah.
But later tonight, we're going to have show and tell. It's going to work a little bit different, so definitely be in the Discord to get the link to join in on that, since Google Hangouts has been sunsetted.
Oh, sunsetted.
Different process now. So definitely make sure that you are in the Discord chat. We have the link up there somewhere. It's discord.gg/Adafruit. Right there. Sorry. I'm just so ready to do the show and tell tonight. I'm so ready for it. Yeah, last week we had a great one. Check it out. It was really nice. I think it's way better than Google Hangouts. So if you'd like to come and participate, please do so. Every participant gets a free as seen on show and tell sticker, a vinyl sticker, so you can put it on your project or on your locker or whatever, your laptop. That's what people do. And then right after that, at 8 p.m. Eastern Standard Time, we have a whole hour of Ask an Engineer with Lamar and Phil Check out all the news, everything going on in the maker community, more.
More products.
Giveaways right at the end of the show too, so definitely tune
You
in
got
for
to
that.
call in. You got to call in, be all nervous. Like, oh no, I'm talking to Lady Ada. Hello.
You usually win whatever the new product is for the week, so
Yeah.
don't miss out on that.
Yes. Cool. I think that's it, folks. Well, thank you so much. Everyone in the chat room say, what's up? Hello. Thank you so much.
Thank you all for joining this week.
Yes.
And don't forget to make
A great day. Bye, folks. Peace.